Okay, our second lesson it was filling our classroom with tennis balls. So this is one of those lessons that you had to be there to get. So what we did was measure our classroom, figure out the volume of it, and then figure out the volume of a tennis ball, divide, and get our answer. So obviously I'm not going to go through all of that in this video. I'm just going to go through a simpler problem and one that's easier to work out that you could see on your test or a quiz. So we're going to look at that, and then we're going to look at the Fermi method as well. So what I'm going to do is just kind of make up a problem here. So let's say that we have a room with dimensions of this. All right, so let's say we have this problem here. So we have a room that's 10 feet tall, 20 feet wide, and 50 feet long. And then it tells us that if 80 tennis balls could fit in a cubic foot, how many tennis balls could fit in the classroom? So there's two things, or there's really one big thing that we need to know, and that is going to be the volume of our classroom. So if we don't know the volume of the classroom, we don't know how many tennis balls can fit in there. So a room is a rectangular prism. So when we do our volume of a classroom, we need to multiply the height times the width times the length. So those numbers are going to be 10 times 20 times 500. So if we plug that into our calculator, we should get 10,000 feet squared. And then the volume of our tennis ball is something else that we would need to know, and it tells us right here that 80 could fit. So we have 80 tennis balls in 1 cubic foot. Change that right there. So if we know that 80 can fit into 1 and we have 10,000, all we have to do is just multiply the 10,000 times 80 to get our answer. And when we do that, we are going to get 800,000 tennis balls. So this is a case where they tell us how many are in there, so we can just multiply those two together and get that. If we knew how much room one tennis ball would take up, we would divide those two, but because it told us right here that we have 80 tennis balls that can fit into a cubic foot, we don't have to worry about that. All right, so let's change the question up to do exactly that. So it says if a tennis ball takes up 0.25 feet cubed, how many tennis balls could fit in the classroom? So we would still have the same two things that we need to know, the volume of the classroom. So we can, we just did that the problem before, but it would be 10 times 20 times 50, which would give us 10,000. And then, of course, the volume of a tennis ball, which would end up being 0.25. So because we know that each tennis ball takes up 0.25, we know that 10,000 is how much is in the room. This time we would end up dividing, so that's a 1 right there. So 10,000 divided by 0.25, so that's something that we can plug into our calculator and get an answer for. And when we plug that into our calculator, we would get 40,000 tennis balls there. So those are the type of problems that you're going to run into dealing with this lesson here. We just completed the Fermi project at this time, but I'll quickly go over the process of that if you haven't, just so that you're prepared to do that when you go and make it up. So our Fermi process is a few steps. Your first step is the original guess with a power of 10. So this is just an estimation. So whenever you're presented with a Fermi question, you just give a quick estimation to whatever the two things are presented in the problem. So if ours being the tennis balls, how many tennis balls could fit in the classroom, we would do a power of 10 estimation for the volume of the classroom and a power of 10 of estimation for the value of, or the volume of a tennis ball. Once we do that, we need to make some assumptions. So in the case of our question, two assumptions that we can make is that all of the tennis balls are the same size and that the classroom is empty, so there's no furniture, so we won't have to account for that. After that, we need to have a list of at least 2 questions, and this is what we need to know. So in the case of our problem, we would need to know the volume of the tennis balls, or just one tennis ball, sorry, and the volume of the classroom. Next would be your research, and math. So in the case of our question here, we would go and get the volume of a tennis ball, and then we would go measure our classroom and get the volume of that. And then lastly, we would come up with the final answer. So we would do the math to get the final answer, and then we would compare that answer to our Fermi or our Fermi prediction right here, or our original guess. So whatever we got for that power of 10. So we would compare those and see if we were on the same order. So this is the Fermi process. So like I said, we have a project over that, so it's good to know the process, how to get from point A over here to point B.